Hello and welcome to Golden Geography. Today we're looking at the Exploring Oceans unit, which is part of the OCR Geography A-level specification. And we are focusing on question 3, how and in what ways do human activities pollute oceans? And there's 3 key parts to this. 3A, there are a variety of pollutants that affect the ocean system. 3B, offshore oil production and transport poses threats for people and the environment. And 3C, the pattern of global oceans currents can disperse and concentrate pollution. So we're going to start with 3A. There are a variety of pollutants that affect the ocean system. So we need to think a little bit about how pollution is getting into our oceans and what is the source of that. Well, in general, we need to think about the difference between point source, so where you can specifically point to a point where that source of pollution is coming from, and non-source point pollution, where we have pollution, but it might be coming from a variety of areas and you can't pinpoint the exact location. So we do have these 2 different categories. And it's obvious that managing point source pollution is a lot easier. If you know where the pollution is coming from, you can stop it. If you don't know or cannot find the source of that pollution, it's a lot harder. So first of all, we're going to think a little bit about fossil fuels. We as human beings use a lot of fossil fuels. We have a carbon-based economy. And when we think about our oceans are being impacted by the human activity on them that is using fossil fuels and burning them. As you can see in the images, that could be anything from cruise ships or container ships, anything that's moving across the oceans that's burning fossil fuels, or even the extraction of oil and gas from our oceans that leads to the flaring of the gas particularly. And those can create pollutants, oil spills particularly, as well as increased carbon in the atmosphere and that diffusion of carbon into our oceans. So fossil fuel combustion and the human activity associated with it is a source of pollution. Some of these areas are starting to change, so particularly cruise ships are looking now at how they can plug in when they're in dock and use electricity supplies from being at dock rather than keeping their diesel generators running, but it still doesn't solve the problem when they're out at sea. We also need to think a little bit about other sources of pollution, other types, domestic pollutions, industrial ones. So domestic, we're looking at things that people are generating within their homes. Hopefully you have a recycling bin at home and a general waste. Unfortunately, very often when we put our bins out on the day that the bin men come, their pressure that they are under to empty those bins quickly may mean that sometimes when those bins are upended and emptied, that parts of the material, the rubbish you put in your bins, fall out and don't get carried away. They might fall onto the street and then get blown into, very often, our local rivers, and then they will flow from our rivers into our oceans. So domestic sources. We can also consider tourism and the impact people have on beaches in terms of dropping their litter and that then getting carried by ocean currents out to sea. We do also have industrial pollutants. So very often when we look at areas of manufacturing or industrial production, they need to be near a source of water. So that might be a river and they use that water in their production, and that water can become polluted by either heavy metals or by dyes used to dye materials or paints, and then that will flow into our oceans. We can also find that sometimes those industrial plants are put near our coastlines, again for the same reason, to have access to water, but also, particularly in developing countries, to use those locations to dump water too, particularly in countries which have less stringent environmental policies. We need to think a little bit about those, particularly when we're thinking about heavy metals. In the production of certain items, water can come into contact with metals, particularly if it's used as a coolant, and that can carry heavy metals into our rivers and into our oceans. And heavy metals play a challenging part in our ecology, and it can impact that as well as ourselves, us as human beings, and can lead to health problems if there is high levels of consumption of water containing heavy metals. China's really struggling with this at the moment and how to address it. As China has become a manufacturing hub for the world, it is now facing some of those problems associated with industrial manufacturing. We also need to think a little bit about nuclear waste. Nuclear activity has been going on for a significant period of time now, and it does result in nuclear waste. And there are questions about what we can do with that. Here in the UK, we have used water as a coolant within our nuclear power plants, and there have been low levels of that have seeped into the water table or into our current oceans. So we need to think a little bit about that one. We also have examples where there have been explosions. Causes have varied, but explosions at nuclear power plants, and that has led to a lot of that coolant water going into oceans nearby. But we do also have dumping, and this is something we'll look at a little bit later on, but we do have countries that have effectively put their nuclear waste into containers, into barrels, and dumped them in the ocean. We find this in the Atlantic Ocean. We also find it a lot off the Somalian coastline. And there are significant problems now arising as a result of dumping of nuclear waste off Somalia. 3B. Offshore oil production and the transport poses threats for people and the environment. We need to consider where we're getting our resources from and how we are moving them. Our oil and gas-based land deposits are being depleted. We are turning to our oceans and the deposits within our oceans to meet the demand we have for oil and gas, and that involves offshore, but also looking at deep sea mining for oil and gas. It involves putting these platforms out to sea, and at sea they are at risk from very strong waves and tides and winds, and that can be difficult. It means you need to consider those when you're constructing it, but it does mean that some of these areas are quite vulnerable, and as a result there can be oil spills in the day-to-day extraction, but also as a result of significant events. We're going to think a little bit about this. It's probably the one you've heard about most, the BP oil spill, which was in the Gulf of Mexico. There's lots of facts here, so feel free to pause the video and write some of these down. But ultimately, trying to extract oil from the deep sea and the pressure that the equipment was under at the deep ocean depths meant that it resulted in this accident, this incident, which caused ocean pollution. So this is about the extraction. We do have tons, unfortunately, of examples of where there have been oil spills as a result of trying to transport material. And the Exxon Valdez and the spill off the Alaskan coastline is a really good example of that, but it is not alone. There are many. If we think about the impacts of oil spills, here particularly the facts relate to the BP oil spill that happened in the Gulf of Mexico, but many of them will result in oil, and because of the chemistry behind the oil, it will float. It doesn't mix very well within the water column, so it floats on the top, and anything that lives or functions within that layer will become, as you can see, covered in oil, and that oil will then prevent those animals particularly from being able to feed or fly, so that environmental impact can be devastating. It can really destroy those food chains and food webs that exist in this environment. It can also have a consequence on our human activities. People don't want to go on holiday to a beach that's covered in oil, so tourism massively declines when you have areas that are impacted by oil spills. And that can have an impact even long after the oil spill has been cleared up. But it also has an impact here on the fishing industry. A lot of people globally rely on fish as their main source of food or protein, and it is a key part of our agricultural economy. But the spill of oil can cause disruption to those food chains, to the death of the species that we are particularly interested in fishing for, and can have significant costs, like you see here with the BP oil spill. The initial cost were estimated to be $2.5 billion US. This is huge. And if you're having that level of economic impact, it will undermine the economic activity of the countries affected, even countries as well established economically as America. It can be managed, it can be cleaned up. And you can see here an image of a boom which is trying to collect all of the oil that's on the surface, but you can see it's not effective. There are areas that are of oil that are escaping beyond the boom, but it is one of the most effective ways of cleaning up the oil out at sea. You can burn it, but that's more difficult. You can take the animals, the birds particularly, that are affected by oil or covered by oil, and clean them up using washing up liquid. Obviously, if you've ever cooked anything with oil, you know that when you clean it up, you use washing up liquid. The same applies here. Oil is very effectively cleaned by washing up liquid. And you can see there's been a whole range of things done to address the BP oil spill, and it has been successful, but it shouldn't have been needed. The spill should not have really taken place in the first hand. And when you're thinking about the management, we need to think a little bit, particularly if we're looking at oceans and offshore activity, think about all of the countries that are affected, their development status. Do they have the capacity to cope? If you're looking at countries that are developing, or particularly very low income countries, they may not have the ability or the resilience to cope with oil spills. 3C, the pattern of global ocean currents can disperse and concentrate pollution. So when we're looking at where pollution is coming from, it can be dispersed quite quickly by ocean currents. And in some cases, that means that the countries or the industries responsible don't take the responsibility because it's not affecting their location. That dispersal means that that problem is passed on to others. But we're going to focus on where it's concentrated. That can cause big problems, but it may also make the management and clear up a little bit easier. So our ocean currents are really important. We need to think a little bit about our ocean gyres, our currents. We need to think about those warm surface areas, particularly that seem to be moving a lot of our plastics within our oceans. Oils too, but we're going to focus a little bit more on plastics here. So those surface currents, those warm surface currents, tend to be most responsible for the movement of plastics and pollution. And if we look at the top picture, we can see the Pacific has a significant loop, and also the Atlantic. There are many areas that will be impacted by ocean pollutions, but those are two big areas where we find pollution being gathered together because of those ocean currents. And we're going to focus on the North Pacific Gyre. It's well known. It's been an example that has been around for a good 15-20 years, and it is a tricky problem. We find in this area plastics being accumulated. There are some plastics that are very easily identifiable, like bottles and bottle lids, plastic bags, some of these, many of these, particularly if you're looking at the Pacific, are coming from traditionally parts of Canada and the US, and they're being blown offshore and then carried into the Pacific. Today, more and more of the pollution in the Pacific is actually coming from Asian countries where they have single-use packets. So if you want a coffee, you don't get a jar of coffee, it's too expensive. You get a single packet which has enough coffee for one drink, and those single-use plastics are being washed into the Pacific via our river systems. The problem is once they are in the ocean, the waves have energy to break up those plastics. Sunlight can cause the deterioration of the plastics too. So even if it enters as a large plastic bottle, it can very often be broken up into microplastics. And they have more of an impact in terms of the effect on biology, but also in terms of being much more difficult to clean up. So here we've got a typical picture of an animal, here a bird, that has been in and around the Great Pacific garbage patch. And this albatross has obviously died because of the number of plastics that it has eaten, mistaking it for food, and it has kind of built up and destroyed its digestive system. It's not just birds, there are plenty of fish, and we get bioaccumulation within our fish as well that are being impacted in terms of the ecosystems as a result of plastics and microplastics. Okay, tricky one. Do have a little think about how all of this can be managed. Plastics, oils, nuclear waste. We need to clean up our oceans if we want to maintain its biodiversity, but how we do that is very difficult. There are lots of people researching it, particularly up at the Oceanography Centre and Southampton University, so it's worth doing a little bit of research into what they are doing. And bear in mind, we really want to do prevention rather than cure, so we want to mitigate, prevent plastics getting into the ocean, oil spills, rather than trying to do cleanup. But really we need both. Okay, pause the video, have a little look at these key areas, use your colours. Green, I really get it, happy with that. Amber, not quite sure, need to look at it again. Red, let's rewind and rewatch. Thanks for listening.